force. So the F represents the force represents as the Cartesian vector. So as we can see here in the problem, the given is F, which is 300I minus 200J plus 150K. It is expressed in newtons. So, as we can see here in the solution, we have the F. So, we need to find R. So, R is equal to 0.3 m, since 0.3 is located at the x-axis. So 0.3 I minus, as we go further as in the y-axis, we have 0.4, since 0.4 is located at the y-axis. And this one illustrates that 0.4 is a positive direction. So 0.3I plus 0.4J. So for the y-axis, we have 0.2. So it is located at its negative quadrant here. There is a positive and this is a negative. So more than a negative. And that is our walls. So minus 0.2K. So now we have to find the unit vector. So the unit vector of UA is equal to 0.3I, since the unit vector OA is found in the x and y axis. Pwede siya x, pwede po siya sa y. And then, galay mag siya, mao na x and y, kaya galay mag siya sa isa na parang x and y. So, ato i-use na direction is ang x o ang y. So, mo na ang atong gamiton is 0.3 plus 0.4. Since dili wala ka natin ang z-axis, so wala siya value. So to find the unit vector, we have to square it. So 0.3 square plus 0.4 square. So UA is equal to unit vector sa OA. So now we are going to proceed to get the moment of OA. So we will use the cross product. So the moment of OA, or I, J, K. So first natin utang is ang unit sa unit vector A. So 0.6 and J is 0.8, and K is 0. So, for VR, ito na din siya i-substitute, which is 0.3 and 0.4, negative 0.2. And then, for the force, 300 minus 200 plus positive 150. So we will perform the cross product. So at first, atong panginahon is I. So atong panginahon nila. So it is equal to MO. K is equal to 0.6. Kaya in-vector mo siya 0.6 na sa gawas. Dayon, pag yung mga tabo na nabili na lang is 0.4 and 0.5. 0.4 times 150 rather minus negative 200 times negative 0.2. So for the J or J component minus 0.8 times 0.3 times 160. 0.3 times 150. Then minus 0.2, negative 0.2 times 300. So since ang K is not 0, so automatic the value of K is 0. So moment of OA is equal to and then itanan yung itanan. I-solve itanan. Sama, pila yung answer? 72. So, pag mo na siya i-add tanan, it will result to 72. Negative or positive? Try daw.
Negative. Negative siya.
Negative, positive.
Negative.
Okay, negative. Ano yung pa? Saan yung unit?
Newton.
Newton
Negative Newton.
per-
N.
Okay. So, ay,
Negative
0.6 man tayo eh.
0.6.
Sorry, mine ko. 6 of
Negative 43.2.
negative 43 I, 0.2 I, plus
negative 57.6 J.
negative, ay, minus negative
57.6 J.
7 and ano niya answer? 7.
Ano yung zero na darang K sa
Sa unit vector niya sa UA. Since ang kanina,
K ba?
wala man nagtanaw gani kay OA axis man ta sa OAN axis. So ang OA axis kay galay man siya sa X and Y na plane. So ang atong gamiton na distance is ang X of Y. So which is ang X is 0.3 meters and sa Y kay 0.4 meters. OA naman siya. OA. Maong nakakamot ka o 0.3 o 0.4 lang. So wala sa J, ay sa K lang.
Problem number 2, we have this problem. Determine the moment of force at about point O. Express the result as Cartesian vector. So in the given problem, we have the given magnitude of F is equal to 120 Newton. F is equal to 120 Newton. And to solve for the moment O, we have this equation moment O is equal to R times F. R is equal moment O is equal to the first product of R times F, which is R is the position vector directed from O at any point. And first of all, let's try to deal with the force F. And the force F is presented as Cartesian vector. As Cartesian vector is equal to F times unit vector BC. So, before anything else, based on the given free body diagram, we have to identify the value of each component. The value of X, Y, and Z. So, the value of Z is negative 2K. It's negative since its direction is going down. And the value of Y is negative 4J. And the value of X is positive 4I. So, since we have this given value of each component, we can use that in solving the Cartesian vector. So, Cartesian vector is equal to using that value, we can use that in solving the UBC. Since we already know the value of F is equal to 120, so using that value, we use this equation 4I minus 4J minus 2K over the square of the sum of each component, 4 squared plus 4 squared, negative 4 squared plus negative 2 squared is equal to negative 4I minus 4J minus 2k over the answer of this is negative 6, huh? Negative 4. I did it positive 4i. Positive 4i. Okay. So we have the UBC. The unit vector of BC. So now let's try to find the force presented as Cartesian vector. So for the Cartesian vector is equal to F is equal to, since we have the value of F 120 times the value of components 4i minus 4j times 2k all over 6. So we have to cancel out. 120 divided 6 is equal to 20. And that is 80i minus 80j minus 4k. So that is the value of the force. Now, to solve for after finding the value of F, we are going to focus on the position vector R. The position vector R. So we see that the C is directed along O and also B is directed along O. So B is OC and OB. So we labeled that as RC and RB. So first is we have to solve for RC. So the value of RC from O to C is 4 plus 1 is equal to 5i, since this from X, it is directed along the X component. And for the RB is equal to from OC to X along X component, which we have the one value of 1 meter, so 1 times I is equal to still I, and from Y component, from along Y component we have the value of 4j, and from Z component is plus 2k. So now, since we already know the RC and RB, we can solve now for the moment O using the cross product. So moment O is equal to I, J, K. I, J, K. So for the I, we have the 5 and J 0 and 0, and for I we have 80, negative 40. So first is we have to solve for the I. So in solving the I, we have to tabularize. We have to cover the I first and multiply using the cross product. 0 times negative 40, so I is equal to 0, and negative 0. So for J, we have to cover the J. So negative 5 times negative 40 is equal to negative 200. And 80 times 0 is equal to 0. So for k, now we have to solve for k. So 80 times, 5 times 5 times 80 is equal to 5 times 80.
200.
400. So negative 400. So negative 400. And 80 times 0 is equal to 0. 80. 80 and 0 is equal to 0. So we have 200 minus 400k. So the moment O, the value of the moment O is equal to 200 J minus 400k, and that is expressed to Newton per Newton meter, and that is our final answer. So, do you have any question, clarification? None so far? Okay.